Welcome to Module 4, Lesson 3, Proportional Relationships and Graphs. So we've talked about proportional relationships and finding that unit rate, which is when we have all these rates that have the same unit rate. It's called a constant of proportionality. We've talked about finding it in tables. Now we're going to find that constant of proportionality inside of graphs. And we're not only going to do that, but then we're going to talk about different spots on the graph and what those points mean. So 0, 0, what does that point mean and what is it called? And in particular, the point 1, comma r or x, y, whatever the variable we want to use is, where r is that unit rate. Okay, so we're going to pay special attention to those 2 points, and we're going to use proportional relationships to solve multi-step ratio and percent problems. We're not paying attention to percent right now, that'll be next unit, but ratio problems for sure. Okay, so first we are talking about our Explore problem, where we have shower heads that are manufactured before 1994, and they use 5 gallons of water per minute. Now, I know you guys don't really care, but as a parent and somebody who owns a house, I like to not use a lot of water because it costs money. So we want to decide if it's a proportional relationship. So it uses 5 gallons of water, so 5 gallons per minute. All right, so I'm going to fill out my table here. So in 1 minute, it uses 5 gallons of water. So my dependent variable is the amount of water used, the gallons, because it depends on how much time I've used it. So my y is the water, and my x, my independent variable, is the time, because it is what it is. So now in this case, if I shower for 2 minutes, I will have used 10 gallons of water with this particular shower head. If I shower for 3 minutes, I will have used 15 gallons of water. But now I know I've used 35 gallons of water, so I can do the reverse and find out that I have showered for 7 minutes. Or I showered for 10 minutes, and in those 10 minutes, I will have used 50 gallons of water. I will be honest with you, it would be awesome if I would actually shower in 10 minutes and not use a ton of water. My husband would be very happy. Based on the table, is this a proportional relationship, and explain our answer? Well, if I go through and I find my rates and find that unit rate, I find that my unit rate is 5 for every single one of them. It's 5 gallons used per minute. So it is a proportional relationship because each rate has the same unit rate or constant, or it does have a constant of proportionality. Okay, so now we're going to take this table and we're going to bring it over to this graph over here. So with our graphs, we have our x and our y. Our x-axis is always our horizontal axis, and our y-axis is our vertical axis. Our y, again, is our dependent variable, so our water goes on our dependent side, and our x is our independent variable, which is our time. So I'm going to plot my numbers. Notice that my intervals are equal. Okay, so I can't go 1, 2, 3, 4, and then all of a sudden go 6, 8, 10. I have to count evenly. All right, and then now my numbers, just like I would put them in a rate, so like my rate was 5 over 1 and then 10 over 2. Now I'm going to put them into ordered pairs. So for my ordered pair, again, I look at this. My ordered pair is always set up as x, comma, y. So my x is listed first, so in this case, it is 1, comma, 5. My next ordered pair would be 2 and 10. And then my next one would be 3, 15, 7 and 35, and then 10 and 50. So the next I would go over to my graph, which was already made for you, and I would plot my points. And I would go over, and so I have to I like to think of it with planes. So a plane has to go across the runway before it can go up in the air. So I have to go over 1 minute and then go up 5 gallons, and I plot my point. I go over 2 minutes and then up to 10 gallons and plot my point. Over 3 minutes and up to 15. And then I don't have a 4, I go all the way to 7. So now I don't see 7 on here, but I know it's going to be between 6 and 8. And then I go up to 35 gallons. And then I go all the way over to 10, and that gets all the way up to 50 gallons used. Okay? And I know this isn't perfect, but what I can do is I can draw a line now from my 1 gallon used through my 10 gallons used. Okay. And I have to be careful right now. I can't start at 0, 0, and I will talk about that in a second as to why I can't just yet. Okay? So now for letter E, we're going to talk about if I use the shower head for 0 minutes, how many gallons of water will I have used? So if I use the shower head for 0 minutes, that means I didn't turn it on, which means no water will have been used. Okay, so if I used it for 0 minutes, 0 gallons of water will have been used. So on my table, it will look like this. 0 time, 0 minutes, which means as an ordered pair, it would be represented as 0, 0. So it'll look like this as an ordered pair. This ordered pair is called the origin. And the origin is really important when it comes to graphing and proportional relationships, because if on a graph, if a number does not go through the origin, if that line does not go through the origin, the graph does not represent a proportional relationship. Right? So in this case, since in 0 minutes, it would use 0 gallons of water, I can extend this line through 0, 0 and show that this indeed is a proportional relationship. So now we're going to take a look at this. The point 23, 125. I want to know, if I were to extend my graph, would this point be on the graph? Well, I can do one of two things. If my graph were large enough, I could extend my line and see if it's on there. Looking at my graph, you can see that it's not big enough, so I can't do that. So I can do some math. I can look at it and say, I know that if I take my time, which is 23 minutes, and I use my equation, y equals my constant of proportionality, which is 5, times x, which is my time, it should give me my gallons of water. So y should equal 23 times 5. If I do that, I should get 125 in order for that point to be on the graph. When I take 23 and multiply it by 5, I actually get 115. Okay, so 23 times 5, when I do the math, I get 15, 2 times 5 is 10, plus 1, I only get 115. Okay, so the point that would actually be on the graph then would be 23, 115, and not 23, 125. So no, that point would not be on my graph. All right, so for identifying proportional relationships, again, we talked about the fact that it has to have that constant of proportionality and it has to go through the origin. Notice with that graph before that we just drew, there was something else that was special about that graph, and I got a couple people here that are looking at it with me, and we noticed that it is very straight and it goes through the origin, and those are two very important pieces. If it is not indeed a line, It is also not a proportional relationship. Your graph cannot curve or zigzag. So it has to be a straight line, and it has to go through the origin. So you'll see that up here in your notes. If the graph is a straight line through the origin, it is a proportional relationship. So we're going to take a look at a house cleaning company that charges $45 per hour. So $45 per hour. So if I put this into a table, you'll see that I have 1 hour costing $45, and then 2 hours costs $90. 3 hours will cost me $135. Okay, and I'm not looking to see if this is proportional, okay, because at this point I know, well, I guess I am looking to see. Right now, I'm doing the math. So 4 hours would cost me $180, and 5 hours would cost me $225. To be honest with you, with 3 little children, I think I'd be getting off pretty cheap with charging this much money. All right, so now I'm going to write my data as ordered pairs. So again, my time is the independent variable because the time is what it is. Okay, they're going to be there as long as they're going to be there. I can't do anything about that, but the cost depends on how much time they're there. So maybe not. It might take infinity to clean the house that I live in. All right, so here we go. So my first ordered pair would be 145. My second ordered pair would be 2 and 90. My third ordered pair would be 3 and 135. My fourth would be 4 and 180. And my fifth ordered pair would be 5 and 225. Okay, again, what we're going to do is we're going to take those points and we're going to plot them on our graph, which is already made for you. Again, time is independent, so it's on the x-axis, and the cost is dependent, so it's on the y-axis because it's our x and y. Like our airplane, we have to go across before we can go up into the air. So in 1 hour, so over to 1 hour, it's going to cost us $45. Halfway up is 50. So I would be just below the 50, you know, do your best because I know it's not perfect. Now bear with me here because I'm using the board and it's a little tough to get a perfect 45 on there when I'm getting down that low on the board. Okay, so now $2 is going, or 2 hours is going to cost me $90. 3 hours, so 3 is going to be between 2 and 4, is going to cost me $135. Again, do your best. 4 hours is going to cost $180, so $180 has to be between $150 and $200. 5 hours is going to cost $225, so $225 should be directly between $200 and $250. Now, let's think. If they spend 0 hours cleaning my house, should I pay them any money? What do you think, Isaac?
No.
No! So it'll cost me $0. So is 0, 0 going to be on my graph?
Yes.
Okay,
Yeah.
so 0, 0 is going to be on my graph. So here, I fulfill one of my requisites that I have the origin. So since I have the origin, I'm on my way to it being a proportional relationship. And now, like I said before, it's not my most perfectly straight line because the graph is a little bit difficult. However, does it make a straight line?
Yes.
Okay, so it's straight and it goes through the origin. So does this graph represent a proportional relationship?
Yes.
All right. All right, so now we have an opportunity here for you to have a your turn problem, do your ride, and then do your graph, okay? And then when we come back, we're going to go over your answer and find out if this was a proportional relationship. All right, so for this one, you should have found that no, it is not a proportional relationship, because even if he plays 0 games, it's still going to cost him $6 because of the shoes. So here, he pays $6 to rent the shoes. So his first point is 0 games still costs him $6 because of the shoes. So even though it's a straight line, he doesn't, so you have to have those two things. So the straight line, we have that, but does it go through the origin? And the answer to that one is no, so it is not a proportional relationship. All right, example number 2. So now we're talking about the parts of our graph. So for the parts of our graph, we're looking at what do the points on our graph mean? Now that we know whether or not the relationship is proportional, we want to look at what do those proportional points actually mean. So here I have a graph that shows the relationship between time in minutes and the number of miles Damon runs. And we're going to write an equation for that relationship. So just like we wrote equations for tables, we're going to write them for graphs. So we're going to choose a point and we're going to tell what it represents. So I chose the easiest point on here because we wanted to talk about it anyways. And I chose the point 10, 1. All right, so the point 10, 1, I have to look at those labels. So here I know that in 10 minutes, okay, so 10 is labeled minutes and 1 is labeled miles. So in 10 minutes, Damien can run 1 mile. Okay, so that's what that point represents. The point represents that it takes Damon 10 minutes to run 1 mile. So then in this case, my constant of proportionality would be 1 mile per 10 minutes. Or more specifically, because we don't want to have labels on our constant of proportionality, K would be equal to 1/10. And then here, write an equation in the form y equals K times X. So y equals 1/10 times X, where y represents the miles that Damon runs, and X equals the time in minutes that it takes him to run. Okay, now if I would have chosen a different point on the graph, so say I chose this point up here. So that point up there would have been 30, because it's always X first, so over 30 and up 3. So that would have meant that it takes Damon 30 minutes. Ooh, this board is not agreeing with me today. To go 3 miles. Okay, so you can choose any point and just make sure to read your labels correctly to figure out what that point means. Okay? So now, what does the point 0, 0 on that graph represent? So what is this point, what does the origin mean here? Well, look at your labels. In 0 minutes, Damon runs 0 miles. Well, that makes sense. If dude is just standing there, he's not going to go anywhere. So it takes Damon 0 minutes to run 0 miles. Makes sense to me. Does it make sense to you guys?
Yes. Yes.
Okay. So for number 3, it's a question about what if. I'd like to have this discussion with you guys in class, so please don't cross it out. We're going to talk about it when you guys come to class next. Okay. All right, and then number 4, you guys have a your turn problem, so I want you to tell me, what does this point represent? What is the constant of proportionality? And then I want you to write the equation for me. So you're going to pause, and then when you come back, you're going to check your answers. All right, so the .46. The .46 tells me that the bicyclist, which sounds funny to me, I'd rather say the cyclist, takes 4 hours to go 60 miles, because it's 4, 6, so over 4, and then up to the 60, so 4 hours to go 60 miles. And what is the constant of proportionality? Well, you could have found that here, so this point here is 1:30, which means 1 hour to go 30 miles. Or you could have found it by doing the math, but it's 30 miles per 1 hour. So K would be equal, that's a K, oh my goodness, is equal to 30. So this should really just be 30. And then the equation would have been y equals 30 times x. All right, and then you guys have your guided practice. So you are going to fill out the tables, and then you're going to tell me whether or not it is a proportional graph. And then you're going to explain why or why not. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.